Hi everyone! We are making good progress with the tank, and this week is all about power and traction. And you might remember that in the first iteration of the tank we used these little motors in here. And as an ESC we use these ESCs in here, which are not bad but not really powerful. And as a battery we use these batteries in here. Those are good, but those are 3S. So we decided to swap to this really beefy Turnigy Aerodrive SK3 motor, which is really powerful. It's used for electric skateboards. But I think that we need to keep upgrading, and that's why I bought these VESCs, which are ESCs for electric skateboards, which are really powerful and also really configurable. So I can adjust braking, traction control and all the parameters of the tank, so it doesn't go too fast or brakes too hard. And the last thing that I needed to change was that 3S battery in there, which I swapped for this, which are 6S batteries, which are much more powerful and torquey than the 3S ones. So let me clean the table, bring my computer and show you what this thing can do. And I did have to botch a bit the connection between these wires and these wires because the diameter of the connectors is not the same, so I had to shim it a bit with a little bit of copper. But for the currents that we are going to be working with on this test, this is going to be more than enough. Also, this one has this very nice USB connector in here, which I can connect to my computer, and I'm using this XT60 to XT90 connector that I showed you last time, so I can use this battery, because again, the currents are not going to be that high. And now I can connect it to the computer to show you what this thing can do, mostly the ESC, the VESC. For example, I can make it run at 2000 RPM, which is more or less this. I can brake the motor, I can make the motor fly on the table. I did put, instead of 2200, 22,000 RPMs, and that's what happens when you play with very powerful motors. It seems to work. 4000 RPMs, or I can make it work at 3 amps, which makes a very soft acceleration. That's braking with only 1 amp, or accelerating with 1 amp instead of the brutality that you saw just a few seconds ago. Very soft. It also allows you to control the motor with the keyboard and go forward and backward and brake it instantly, which is very dangerous. So that's what is going to go on the tank. See, this takes almost no effort. A tank! Now I will try to complete one entire thread on one side with its sprocket and the idler to see if we can move it really fast. You will have to come to this side of the table. And I will need to make some space on the table so I can assemble the final sprocket that is going to go on the traction axle. And these two parts in here are the ones that are going to make the new sprocket. And it is smaller so I can have more torque, because the motor was already really fast and I added another 3S to the battery. So it's going to be fast enough, so I think we should add some torque to it. So let's assemble it, join the two halves, and the sprocket is ready. And as the old idler was damaged on the accident of the last test, I did a new one, on which I've already installed the bearing on this side and on this side. And now I will show you what did I think of to solve the thread tensioning system, for which I need to cut some rods and I did print some parts, so I will show it to you as I put the parts on the tank. First I need to cut two rods to this exact width, 1 and 2. And now I need a rod that goes through the entire front of the tank, like so. One spacer, one in the other side, another idler, the end one, and with the one on this side I should mark where to cut around here. So we already have the idler axle on one piece, and now I need to put bolts on these little clamps in here. And the bolts are in, so axle in, bracket spacer, idler, idler, end bracket, and the other end bracket, fasten the brackets, fasten the other ones, and now both idlers spin, and this thing moves like this. So there is only one piece left to install in here, which is not one but two 3D printed parts that will go in here. And as you can see, those two have regular springs that go in this little hole in here, and which springs like this. This goes in here, which springs like so, and once I insert this in here, now this should spring like so. Cool! It works! And I will do the same in the other side. It works! Whoop. I'm starting to worry because I'm doing too many things that work first time and I'm not used to that. Well, this is not first time, but this is the first time that I try that. I know. Okay, now let's go to the... Let's bring the other side here because I don't want to go... you know. So now let's substitute this sprocket for the smaller one, remake the axle, install the motor, belts and everything to see if we can finally see a thread on this thing, so we can get an idea of how it's going to look. Well, it is in, this is locked into position, the belt is tightened, not like the last time that I did the test where it was screaming because it was skipping. So I will try to connect one of the VESCs in here with the battery and the controller before installing the thread. Again, I'm using these thin pieces of adhesive copper rolled so I can shim the connectors because I don't have the right size of bullet connectors. But don't do this at home, it is not a good idea. it doesn't move as expected, so I will connect the VESC to the computer, which is one of the great things about VESCs, which I'm starting to learn how to say. Okay, I have no idea what I'm doing, as almost always, but I did manage to set the cutoff voltages of the battery on the VESC, and now this thing flies. Now it can chop my fingers, so I have to be really careful. I cannot break this anymore with my hand. So this is the point where this is starting to get interesting. Now, so you see what I'm talking about? I've set the motor to 1000 RPMs and I'm trying to stop it with my hands, and the belt is skipping before I can stop it. So now I will... give me a second. I cannot stop the... I will fasten the belt a little bit more and I will try to see, but I cannot stop it with my hands. We have lots and lots of torque. I don't think that I'm only going to be able to ride this thing. I will be able to climb with this thing. Woo! Woo! Come on, Ivan, run, run! Now I think that I'm going to have to put a really big fan inside of this thing to cool the motor. Well, I cannot fasten the belt anymore, but this is going to be super strong. Woohoo! I have these two tank threads from last time and I will try to join them and make one. Also trying to mix the red and black color so you can see the tracks moving when I do the test. Installing a new link or closing a thread is now much easier because I just now remove the spring on this side and I just now need to install it again. Like so. And the belt is tensioned. And now I need to share with you something terrible that just happened. I did the design of the sprocket wrong. I did mess up the pitch of the thread and it will not work. I will try it anyway, but it will not work. This thing is going to fly. I'm really sorry about the design of the sprocket. I really did want to give you this week a moving tank, but now I have to redesign it and reprint it just to make the test. Sorry. So I don't have time to do anything else this week. So I will work as fast as I can to redesign the two new sprockets with the correct pitch so we can see this thing. This motor is incredibly powerful. It's going to destroy the threads, but this is going to be awesome. So that's it for this week. If you want to see my next video early, there is a reward on Patreon for just that, watching my videos early. Thanks a lot for your Patreon support, to all of you that make this brutality possible. Don't forget to comment, like and share my videos, it helps a lot. And now please go and make something! Hehehe